to admin of code 2017. Today we're doing day 5. A maze of twisty trampolines all like. An urgent interrupt arrives from the CPU. It's trapped in a maze of jump instructions and it would like assistance from any programs with spare cycles to help find the exit. The message includes a list of the offsets for each jump. Jumps are relative. -1 moves to the previous instruction and 2 skips the next one. Start at the first instruction in the list. The goal is to follow the jumps until one leads outside the list. In addition, these instructions are a little bit strange. After each jump, the offset of that instruction increases by 1. So if you come across an offset of 3, you would move 3 instructions forward, but change it to a 4 for the next time it is encountered. For example, consider the following list of jump offsets. 0, 3, 0, 1, -3. Positive jumps forwards move downward, negative upward. For legibility of this example, these offsets values will be written all on one line, with the current instruction marked in parentheses. The following steps will be taken before an exit is found. 0, 3, blah, before we have taken any steps. 1, jump with offset 0, that is jump not at all. Fortunately, the instruction is then incremented to 1. Then we jump 1 onto this. Because instruction we just modified, we jump there. The first instruction is incremented again to 2. Then we jump here, jump all the way to the end, leave 4 behind. So we increment and then we jump. Go back to where we just were by -3, but we also increment that to -2. Jump 4 steps forward, escaping the maze. Okay, I have a puzzle input. Let's check it. Maybe I'll do this example first. Let's check this. The list of integers. Even the -3 is there. Then we go jump. We start in the first instruction. Done is false. While not done, we check instructions. Instructions C. If C not in instructions not indices, done equals true. Okay, we're not done. We go. We have to jump by the instruction. Okay, it's not a map. Then we take the instruction of C and increment it. We have to make it a mutable list. And then C equals C plus jump. And I think that's already it. What's the question? How many steps? So we need to count. I equals 0. Like this maybe. And we print I, 5 steps. 5 steps. Okay, then we check the real guy. We've met this many steps. And that's it for part A. Now the jumps are even stranger. After each jump, if the offset was 3 or more, instead decrease by 1. Otherwise, increase it by 1 as before. Using this rule, with the above example, the process now takes 10 steps. We can try that. So now we go if 3 or more decrease by 1. This one. If what? The offset was 3 or more. Yeah, it's C. Oh no, that's instruction C. Jump equals 3. 3 or more. Not negative, right? 3 or more. Then we -1 else. Keep this as we wanted, as we had it. Then we see what happens. 10. So then we get this number. And that's it. So let's go through it again. We jump the amount of steps indicated in the list, forward or backward in the list. And every time we jump, we increase the number that was where we jumped away from by 1. That's the part 1, where we just do, well, we can just do this. We say we're not done yet. While we're not done, we check if C is in the indexes of the instructions. If it's not, that means we jumped outside, so we're done. Otherwise, we increase I, so I count how many steps we've been taking. We get the instruction to how much to jump. We increase the instruction where we were by 1, and then we jump the amount. And that gives us part 1. Part 2, we do the same, but if jump is greater than or equal to 3, which is the instruction, then we actually decrease it. Otherwise, we increase the instruction at the point where we are in the list. Kind of C is kind of a pointer in the list, and then it points to these brackets here. Where we're at 0, and then we're at 1, then we're at here, and then we come back, and then we're here. This is the pointer, the index of in the list. Let's say IDX is the index. And I is steps. How many steps? So every time we do one thing, we increase the steps. Unless we're done, then we're done, and we print the steps. So that's it. Enjoy the rest of your day.